Good morning, everyone. My name is Preeti Srivastava, Assistant Professor, Electronics and Communication Department, BBD University. Today, I am going to present a lecture on the topic Microprocessor and Interfacing. Code is BCS 3502. Today, this lecture I'm going to present on a very popular device that is 8255 chip that is basically an input-output device interfacing chip. 8255 that is called as programmable peripheral interface chip. It is a popularly used parallel programmable input-output device. It consists of a 40-pin IC chip, and in that 40 pin, 24 pins are assigned to the input-output ports. Basically, it has three 8-bit ports, port A, port B, port C, and each port consists of the 8-bit lines. Further, the 8 bits of the port C is divided into two groups of 4-bit each. It is compatible with almost many of the microprocessors. It can be programmed in two modes. First is your bit set reset mode. Second is input-output mode. The bits of port C gets set or reset in the bit set reset mode, and the other mode is input-output mode. In the input-output mode, further it can be classified into three modes, that is mode 0, mode 1, and mode 2. Mode 0, when the ports are simply giving the input-output instructions. Mode 1, when the ports are giving the input-output instructions as well as the handshaking instruction. In mode 2, the bidirectional input-output handshaking function is performed. Here, we will see the pin diagram of the 8255 PPI. It is a 40-pin IC chip, and here you can see in this 40 pins that in this 24 pins are distributed in the three ports, port A, port B, port C. Along with that, we have read pin, chip select pin, ground pin, A1 and A0, address pins that are connected to the address bus of the CPU. And there is a write pin, reset pin, and these are your data bus buffer pins, that is from D0 to D7. And 26 pin is your VCC, supply pin. Further, in the block diagram of this 8255 PPI, we will see the functions of each and every block in detail. Here in the functional block diagram of the 8255 PPI, you can see that there is a data bus buffer block. This data bus buffer block is connected through the bidirectional data bus pins, that is from D0 to D7, and it is connected to the data bus of the processor. Next, there is read-write control logic block. In this read-write control logic block, various control signals are provided by the pins read, write, A1 and A0, reset pin, chip select pin. These control signals are given to the two blocks, group A control and group B control. This group A control is associated with the group A port A and group A port C upper pins. This group B control group is associated with the group B port B pins and group B port C lower pins. So these two control blocks are going to give command to these ports that which port will be active at what time. Now let's understand the operation of each unit separately. There is a data bus buffer block. It is used to connect the internal bus of 8255 with the system bus so as to establish proper interfacing between the two. This data bus buffer allows the read and write operation to be performed from or to the CPU, to the input-output ports. The buffer allows the passing of data from ports to or control register to CPU in case of write operation, and from CPU to ports or status register in case of read operation. There is a read-write control logic block also. This unit manages the internal operations of the system. This unit holds the ability to control the transfer of data and control of status word both internally and externally. Whenever there exists a need to fetch the data, then it accepts the data, accepts the address provided by the processor through the bus and immediately generates command to the two control groups, group A and group B, for the particular operation. Now let's see the function of the group A and group B control. These two groups are handled by the CPU and functions according to the command generated by the CPU. The CPU sends control words to the group A and group B control, and then in turn sends appropriate command to their respective ports associated with this group A and group B control. Further, there is a chip select pin. It is an active low pin. Whenever there is low signal on this pin, it enables the communication between the 8255 chip and the processor. We can more specifically say that the data transfer operation gets enabled by an active low signal at this pin. There is a read pin. It is a signal used for read operation. A low signal at this pin shows that CPU is performing read operation at the ports or status word. Or we can say that 8255 is providing data or information to the CPU from the data buffer. Write operation, it shows write operation. A low signal at this pin allows the CPU to perform write operation over the ports or control register of 8255 using the data bus buffer. Further, there is A0 and A1 pin. These are basically used to select the desired port among all the ports of the 8255, and it is do so by forming conjunction with the read, write, reset, chip select pin that is given in the read and write control logic block. Reset pin. It is an active high signal pin that shows the resetting of the PPI. A high signal on this pin clears the control registers and the ports are set in the input mode. Here, in the previous functioning of the blocks, we were talking about the control register. The control register is provided by the CPU of the processor. So whenever the 8255 is operating in first BSR mode, then this control register of 8-bit is provided to the 8255 chip. Here you can see that whenever it is operating in the BSR mode, then D7 bit is always 0. D0 bit, that is set or reset, and D1, D2, D3 decides that port C, which bit is operating. So here you can see that this table depicts the meaning and purposes of all the bits of the control register word. Bit 0. When the bit 0 is 1, then port C is selected by the bits 3, 2, 1. When this bit 0 is 0, then port C is reset, selected by the bits 3, 2, 1. Now the bits 3, 2, 1. Whenever there is low signal 0, 0, 0 on the bits 3, 2, 1, then bit 0 of port C is selected. Whenever there is 0, 0, 1 on the bit 3, 2, 1, then select bit 1 of port C, and it goes like on. Bit 6, 5, 4, they are don't care pins. So generally they are loaded with a 0, 0, 0 signal. Bit 7, that is 0. This indicates that the 8255 chip is operating in the BSR mode. And port C bit, that is set or reset. Now here we can see the control register of the input-output mode. This is again 8-bit register. Now D1, this control register function, that is depicted in detail in this table. Here, whenever the bit 0 is 1, then it indicates that port C lower bits PC3 to 0 are input. Whenever the bit 0 is reset, then it indicates that port C lower bits are performing the output function. When the bit 1 is set, port B is performing the input function. When it is 0 reset, then port B is performing the output function. When bit 2 is 1, the port B is in mode 1, and when it is 0, the port B is in mode 0. When the bit 3 is 1, the port C upper pins are doing the input function. When the bit 3 pin, when the signal at bit 3 pin is low, that is reset, then port C upper bits are doing the output function. When the bit 4 is set, then port A is acting as, for input function. When the bit 4 is reset, then port A is performing the output function. Now, bit 6 and 5, whenever they are 0, 0, then port A is in mode 0. Whenever the signal on this bit is 0, 1, port A is in mode 1. When it is 1, 0, then port A is in mode 2. Whenever it is 1, 1, then port A is in mode 2. Bit 7. Bit 7 must always be set. This indicates that the 8255 chip is programmed in the input-output mode. This table depicts the control signals. Whatever control signals are given by these pins to the read-write control logic pin, here you can see that corresponding to the signals on the pin A1, A0, read, write, and chip select, the input and output operation are performed. So here, whenever we are going to do the read operation, then all the pins of the read operation are kept low. Read pin signal is kept low because it is an active low pin. Then in this case, the port A, the data from port A of the 8255 chip is read to the data bus of the CPU. Likewise, depending upon the signals on the A0 and A1, the port B is read to the data bus of the CPU. For 10 on A1 and A0, the data on the port C is read to data bus of CPU. Whenever we are going to perform write operation, then the signal on this pin is kept low. And depending upon the signal on the A1 and A0 and write pin, the write operation is performed. The write operation is performed from the data bus of the CPU to the port A of 8255 chip. Correspondingly, from data bus to the port B, depending upon the signals on the pin A1 and A0, from data bus to the port C, and whenever all the pins are high A1, A0 and read bar, then the data bus to the control register. Now, we talked about the mode 0, mode 1, and mode 2 in the input-output mode. So what happens in the mode 0? Let's see. In this mode, all the three ports, port A, B, C, can work as simple input function or simple output function. Here, there is no interrupt handling capacity. In mode 1, handshake input output mode. This is also called as handshake input output mode or stopped input output mode. In this mode, either the port A or port B can work as simple input port or output port, and port C is used for handshake signal before actual data transmission. It has interrupt handling capacity and input output are latched. With one example, let's get the clarity that how we are going to perform the handshake signal. Here, you can see that the processor is connected to one device, printer, that is your output device. A CPU wants to transfer data to the printer. In this case, since the speed of processor is very fast as compared to relatively slow speed of the printer, so before actual data transfer, it will send handshake signal to the printer. This handshake signal is given by stop signal, that is STB signal, to the printer for synchronization of the speed of the CPU and the peripherals. Now mode 2. This is your bidirectional data bus mode. In this mode, only port A works and port B can work either in mode 0 or mode 1. Here the 6-bit port of port C are again used for handshake signal. It also has interrupt handling capacity. Thank you very much. This was all about the 8255 programmable peripheral interface chip.